Okay, give me 1 second to resize this. So this says the domain over the real numbers of this function is in the form of either from negative infinity to some value a or from some value a to positive infinity. First thing we'll do is find what a is. The thing to keep in mind with square roots is that square roots have to be greater than or equal to 0. You can't take the square root of a negative number without getting some imaginary number. This should be really -1 to make actual sense. So since we're talking about in the real numbers, I can't have negatives inside the square root. So I have to make sure that the thing inside the square root has to be greater than or equal to 0. So the thing inside, -4x plus 18, has to be greater than or equal to 0. So now I'm just going to solve this. I subtract 18 from both sides. Divide by -4, divide by -4. Remember, when you divide by a negative, when solving an inequality, you have to flip the sign. So this becomes x is less than or equal to positive 18 over 4, which is 4.5. So x is less than or equal to 4.5. So if you're looking at a number line, here's 4.5. X can be anything less than it, up to and including 4.5. So that's our boundary. So our a value is going to be 4.5. And since it could be 4.5 or less, it's going to look like this, from negative infinity up to 4.5. So this will be yes, and this will be no. If it was greater than or equal to 4.5, these would be flipped. Okay. This next one here, let me resize it. It says find the domain in the range of this function. The domain is just all x values. So if I'm looking at the domain first, it's the leftmost x value to the rightmost x value. So it looks like the leftmost x value is -1. That was a good start, -1. And we use a bracket because it's filled in, which means we're including it. And the x values go as far right as 2. But there's an open circle there, which means we're not including 2, so we use a parenthesis. The range is going to work the same way. It's just with y values. The lowest y value is this point here, which is on the y value of 0. It's open circle, so we use a parenthesis. The highest y value is not this point, it's here, which is 4. And we include 4, so we use a bracket. Okay, now some algebra here. When you have function notation, you're just going to simplify this equation or this expression here with whatever is inside the parentheses, replacing the variable x. So this first one, f of x plus 1, I'm just going to rewrite the expression, but replace x with x plus 1. So instead of x squared, it's x plus 1 squared. So this is 8 plus, now I can FOIL this. X plus 1 squared is just x plus 1 times x plus 1. So I'll do first x squared, outer is 1x, inner is 1x, and last is 1. So I have x squared plus 2x plus 8 plus 1 is plus 9. So this is going to be x squared plus 2x plus 9. The second one is just going to be f of x minus f of -5. So first thing I can do is just figure out what is f of -5. It'll make it easier. F of -5 is 8 plus -5 squared. Make sure you use parentheses. f of negative 5 is 8 plus negative times a negative, that's a positive 25. So this is 33. So if I want to figure out what f of x plus f of negative 5 is, I'm just going to rewrite f of x is 8 plus x squared plus f of 5, which is 33. So I'm left with x squared plus 41. That's it there. And the last one, don't make it harder than you have to. It's saying, you kind of went backwards, I think. Based on the table below, evaluate f of 5. So you saw 5 here and thought it was 0. But this is saying x equals 5, right? The thing in the parentheses is what we're replacing x with. So we're looking for x equals 5 here. So when x is 5, f of 5, the function value at 5 is 56. Okay, f of 0 equals 5, but f of 5 equals 56. This is the thing we're putting into the function. This is the thing we're getting out.